Hey guys, Ms. Smith here. I am going to go through the beginning part of section 2.6, which is titled Inverse Functions. Um, so the basis that you probably have for this understanding of inverse functions, you might have talked about it a little bit in Algebra 1, but at the most basic level, we've talked about inverses when we solved equations, meaning if we had something like x plus 6 equals 10 and we're solving for x, we would say what's the inverse or what's the opposite of adding 6? And that would be subtracting 6. We'd do that on both sides and we would get an answer. So addition and subtraction is one set of inverses that we've talked about. So that's what we're talking about when we talk about the additive inverses of a number. In terms of multiplication, say we had 3x equals 9. That's another example where if we were solving that equation, we would say, okay, the inverse of multiplying is to dividing, or the opposite of multiplying is to divide. So that divided by 3 undoes the times 3, which gets the variable by itself, which is what we want, so that we can get answers. So that's kind of the most basic level of inverses, at least that we've talked about up until this point. Today, we're going to talk about the actual inverse of a function itself. So if we have a function where x is being multiplied by 3, its inverse is x divided by 3. So they can be as simple as that, or they can look a little bit more confusing like these two do. But one of the ways where we can check is by using the idea of the composition of functions, which we've talked about already in this chapter. So basically what this says, it probably looks like a bunch of foreign language to you guys, but if we take a function f and we have some input value x, and we get out a value b, and then we input that value into our other function, and it brings us right back to the same starting input value that we had, that's when we consider or we know that things are inverses of each other. So that's what happens when we deal with numbers. When we do it without inputting an actual value, we just keep it in terms of x. When we see that the composition, so g of f of x and f of g of x, both end up equaling to x, that's another way to show it. So we're just going to look at very simply kind of the number version today. So if we look at these two functions, so we have f of x, and then we have g of x. So those are our two rules. And we're just going to kind of follow in order of what they ask us to do. So the first thing says to calculate f of 5. So remember what that means. That just means, hey, use this rule called f and input a value of 5. So if we do f of 5, this rule says to take 3 times that input value plus 7 divided by 2. Well, that input value is 5. So if we simplify that, I'm going to scroll in a little bit, or okay. We get 3 times 5, which is 15, plus 7 in the top, divided by 2. And we get 15 plus 7, which is 22 divided by 2. And 22 divided by 2 is 11. So in this first example, when we do f of 5, input value of 5, we get an output value of 11. Well, then they ask us to find g of 11. So now we take this other rule, g, which says to do 2 times some input value minus 7 divided by 3. So my input value is now 11. So if I go through and do that, I get 22 minus 7 divided by 3, which is 15 divided by 3, which is 5. So while they asked us to do these separately, basically what these are showing is that if we start with an input value of 5, we get an output of 11. When we put that output value into our other function and it brings us right back to our original input value, basically this function g is just undoing everything we did in f. So these two functions we would consider to be inverses of each other. All right, we can also show that. With the situation like this. So they say to find f of g of -1. So if these truly are functions that are inverses of each other and undo each other, when I plug in -1 to g and I get my output value, and then I plug that output value into f, I should get a final answer that is the initial input value that I started with. So let's see if we can do that. Remember, when we have a composition here, we always start with the inside first. So g of -1 equals 2 times our input value minus 7 over 3. So our input is -1. We get -2 minus 7 divided by 3. Just be careful here when -2 and -7 is a -9. And -9 over 3 is -3. So now, remember, once we find the output value for g of -1, we take that output value and we plug it into f. So now we're using this rule, which says 3 times some input value plus 7 divided by 2. So again, this is my new input value. We get -9 plus 7 divided by 2, which is -2 divided by 2, which is -1. So it kind of came full circle. Our original input value, plugged it in, got an output value, plugged that output value into our other function, and it brought us right back to that initial input value. So kind of the shortcut of this is if we do know that two functions are inverses of each other, then when we see a problem like this, we know the answer to this, the final answer will be 5. If f and g undo each other, then our final answer, our second answer, which is what counts when we do composition, should be the original input. And again, we can show that. So if we do g of 5, do it one more time here. So our g function says 2 times x minus 7 divided by 3. So plug that in. We get 10 minus 7 divided by 3, which is 3 divided by 3, or 1. And then we take that and plug it into f, so f of 1. And our f function says to do 3 times the input plus 7 divided by 2. So again, we're plugging in 1 there. We get 3 plus 7 divided by 2, which is 10 divided by 2, or 5. So again, we show our original input becomes our second output. So we know that when we plugged 5 into g, we got an answer. When we plugged that answer into f, f basically worked backwards and took us right to our original input. So that's what inverse functions do. They basically undo each other. And so in the second one, or this last one, that goes together there. In this last one, it says, without calculation, determine the value of f of g of pi. Well, because we already know, because f and g are inverses of each other, the answer will be pi. And this could say f of g of anything. As long as f and g are inverses of each other, whatever value we're plugging in initially will be the value we get out in our final output. So this could be f of g of star, and the answer would be star. Or f of g of heart, and the answer would be heart. Hopefully that's not confusing you more, but hopefully that makes a little bit of sense. So, and on this page, this is the second page of notes. It's just kind of a visual of basically showing what happens. I don't know if for you guys, but this visual is a little bit confusing, I think, even to me. But it says the two functions that we just saw in exercise 1 are inverses of each other because they literally undo each other, which we talked about. The general idea of inverses f and g is shown below in this picture. So basically it's saying we have this input value and we're plugging it into F, and we get this output value of B. Okay, and when we plug that B, which is the input or domain of G, then it undoes it and gives us an output of A back. So it's kind of a vicious cycle, I guess, is one way you could look at it. But anyways, that's what inverses do. And there is a certain way that we write inverse notation, which is what this next part says. It says if a function y is f of x and has an inverse, this is the notation right here. In words, this is the inverse of f of x. We can say f negative 1 of x. That's the inverse of f. And one of the big things that we'll start looking at in the second day of 2.6, which we won't do until next week, kind of comes out in this table. So some general things. So notation wise, if we have an original function f of x, its inverse, this is the notation for it. Basically what happens is that our original input and output values get flip-flopped in our inverse. So what is our input in our regular function becomes our output in our inverse function. And what was our original output in our function is the input in our inverse function. So the easier way to say that is your x and your y values basically just switch spots. Okay, so we'll look at this idea in terms of a table of values and a graph and the idea of inverse functions next week. Okay,